What's up guys, welcome back to our channel. This video is the first in our series of deep dive videos on each section of the semiconductor industry. In each video of this series, we'll take you through every single section of the semiconductor industry to review how each section of the industry contributes to ultimately manufacturing advanced computer chips. We'll go through fabless chip design companies, fabless non-chip design companies, EDA and IP companies, foundries, machinery and equipment manufacturers, component manufacturers, OSATs, IDMs, and OEMs, and teach you everything you need to know about how each one of these industry sectors contributes to ultimately making the technology that runs our world. So let's go. This video, as the name suggests, is about fabless chip design companies. In the 1980s, AMD founder Jerry Sanders, in reaction to the trend of many semiconductor companies becoming fabless, coined a phrase that became the mantra of the traditional semiconductor companies. He said, "Real men have fabs." I wonder now what the 89-year-old Sanders thinks about the fact that his company, AMD, in 2009 sold off their foundry division, becoming a fabless chip design company, and that their current CEO, Lisa Su, is a woman. I guess Jerry Sanders learned that real women don't need fabs. So in today's video, we're going to talk about fabless chip design companies, the fabless concept, and why it was so revolutionary for the semiconductor industry that it upset industry icons like Jerry Sanders so much. Two of the world's top 10 most valuable companies are fabless chip design companies, NVIDIA and Broadcom. In fact, NVIDIA is by far the world's most valuable company, with a current value of $4.4 trillion, compared to Microsoft, the world's second most valuable company, who has a value of just $3.8 trillion. So clearly there's some serious money in the semiconductor industry, and many of the top companies are fabless. So if you want to understand more about the fabless concept, learn more about the top fabless companies, and understand how they work together with the other parts of the industry to create advanced semiconductors, be sure to watch this video. And if you want to expand your knowledge of the semiconductor industry, be sure to subscribe to our channel, as we share weekly videos on the industry. The first fabless chip design companies started in the early 1980s. These were companies like Chipson Technologies, Linux, Altera, and Qualcomm. I'm going to guess that you've probably only ever heard of one of those companies. More on them later. As startups, these companies had incredible ideas for how to revolutionize the world with advanced computer chip designs. But the biggest problems they faced were they didn't have the hundreds of millions of dollars that it costs to create a semiconductor fab, and they were artists, not builders. These people loved to innovate and change the world with their designs, but they didn't necessarily want to spend all the time focusing on the advanced manufacturing to actually produce their designs. At the time in the early 1980s, fabless chip companies also had a major problem to contend with, which also explains why there weren't many of these companies yet. Who would manufacture their chips? If they're just going to focus on design, surely they need to figure out some company that can actually do the manufacturing of their chips. But the problem they faced is, the only option they could consider, of course, would be companies with fabs. But these companies at the time, like Intel, Texas Instruments, AMD, and others, were all IDMs, meaning they manufacture chips, but they also design their own chips, meaning they would directly compete with these fabless chip companies that they would manufacture their chips for. This meant that IDMs would obviously give preference to their own chips first, using the most advanced lines and reserving capacity for their own chips over their fabless customers. At the same time, of course, fabless companies would be very concerned about handing over their designs to the IDMs to manufacture their chips, knowing these IDMs are also their biggest competitors in the chip design industry. So, in stepped perhaps the most important person in the history of the semiconductor industry, outside of the original inventors of the transistors and the integrated circuit, Morris Chang. Morris Chang is a Chinese-born American who left China after the Chinese Civil War to settle in the US. He went on to study electrical engineering at Harvard, MIT, and Stanford. In the early 1980s, Morris was a top semiconductor engineer and executive at Texas Instruments in his mid-50s. As a young engineer at TI, he even worked under the inventor of the modern computer chip, Jack Kilby, whose integrated circuit revolutionized the computing world. But by the mid-1980s, Chang felt that he had reached as high as he could go at TI and was ready for a change. He also realized that the current structure of the IDMs handling both design and manufacturing of semiconductors was inefficient and becoming increasingly unsustainable, with the pace of Moore's Law requiring more and more investment into advanced manufacturing. Then in 1985, Morris visited Taiwan and was approached by the Taiwanese government about starting a Taiwan-based semiconductor company. He accepted the government's proposal on one condition. The company that he would create, TSMC, would have to be the world's first pure-play foundry, meaning they would not design their own chips, but would focus solely on manufacturing the most advanced chip for their fabless chip design companies. Another issue that the semiconductor industry faced at the time that also contributed to the fabless transition was geopolitical competition. In the 1980s, Japanese semiconductor fabs like Hitachi and Toshiba began outcompeting their American counterparts in precision manufacturing, and they did so at much lower costs, as labor costs were much lower at the time in Japan. This made it very hard for American fabs to compete with the higher costs associated with manufacturing in the US. So these two trends, the advent of pure-play foundries and geopolitical competition with Japan in the 1980s, helped accelerate the fabless trend. The 1980s and 1990s saw the advent of many of the top fabless companies of today, such as Qualcomm, NVIDIA, Broadcom, and MediaTek. And by 2009, even Jerry, all men have fabs, Sanders' company AMD, sold off its fab, joining the ranks of the fabless semiconductor companies. So now that we've reviewed what a fabless chip company is and their history, let's talk about what they actually do. Just as the name suggests, these companies do not have fabs and they design chips, meaning they just focus on the complex process of designing chips and leave manufacturing to the foundries they contract with. But they really do much more than just design. In fact, they are the company that's in charge of coordinating and managing the entire chipset production process. They do this by providing their designs to foundries for their logic and memory chips, purchasing all needed components from suppliers, and contracting with OSATs for their assembly and testing. All of these steps are decided on and managed by the chip design company, whether they are fabless chip design company or fabless non-chip design company. So the chip design companies are responsible for part A and part Z in the semiconductor production process, meaning they first come up with the design, everything else happens in the middle, and then they are the ones that sell a finished chipset to the OEM. Fabless chip design companies use EDA, or electronic design automation software, to design their chips. Using this software, they can model all of the details of a chip down to the transistors. They can also model a chipset or a chip on top of a motherboard, accompanied by all other components of a chip system, like substrates, passive components, other logic chips, memory chips, and connective wiring. Once the design has been created, the engineers can use emulation tools or software that emulates real-world conditions to test the power, performance, and area of a chip or chipset. PPA, or power, performance, and area, are three key metrics for chip quality. The goal of most advanced chip designers, especially those for mobile applications, is to create chips that use the least amount of power, take up the smallest area, and have the highest performance. Essentially, they want a small chip that performs well and doesn't take a lot of power, which is especially true for battery-powered devices like PCs and cell phones. Once the design has been finalized and passed emulation tests, the fabless chip design engineers will then request samples so that they can test the real chip or chipset after it has been produced. This requires each supplier to provide samples of their components to the chip design company. This includes logic chip samples, memory chip samples, and passive component samples. Once the chips have been assembled, they are then tested. If they pass the tests, then the chips will be ready for mass production. If they don't pass the test, the designs are tweaked and tested again. If any component doesn't work as expected for the chipset, new versions are ordered and then assembled and tested again. This process is then repeated until the design is complete. Once the chipset is put into mass production by the design company, which means that it will now be mass produced and sold to an OEM, all of the steps in the supply chain are ready for production. Orders are reserved to the foundries for logic and memory chips, components are purchased from component suppliers, and then everything needed to build the chipset is sent to the OSAT company, whose space has been reserved for the production of this chipset by the design company. All of these suppliers are chosen by the design company per project, meaning the design company can choose whichever foundries, component suppliers, and OSATs they want. This is generally based on whichever ones provide the best combination of price and performance for a specific project. They can and do choose different sets of suppliers and OSATs for different projects. The OSATs then assemble and test the chipset according to the design of the design company. Then the finished chipsets are sent on to their end customer, or OEM. So I hope this explanation helps you understand what fabless chip design companies actually do and the role they play in the wider semiconductor industry. And I hope you understand now that they are not only just responsible for design, but actually play a critical role in coordinating and managing the entire chipset production process. So now that we've learned what fabless chip companies are and what they do, let's talk about some of the biggest fabless chip design companies in the world. There are 5 main chip design companies who dominate the global advanced chip design market. Each of these companies focuses on designing specific types of chips for different applications, allowing each one to service a different portion of the market. So in some ways, these companies are direct competitors, in some ways they can be partners, and in other ways they don't interact at all. And as mentioned earlier, these companies only design advanced chips, like CPUs and GPUs. and entire chipsets like SoCs. They don't make analog or power chips, as these chips are usually made by IDMs. The advanced chips are the chips that are so technically complex that they require a company to specifically handle their design on their own. The world's most valuable company is a fabless chip design company, NVIDIA. NVIDIA is a fabless chip design company that originally made GPUs, or graphics processing units, which is a name created by the company for their chips which render graphics on display screens for gaming applications. GPUs were specially created processors which accompanied the CPU of a device. CPUs, or the central processing unit, are the main chips that process all of the digital information on a device. CPUs use sequential processing, meaning they process bits of information one at a time. But for rendering graphics, CPUs weren't sufficient, as processing sequentially was too slow to change millions of pixels on a display screen instantaneously. So in the late 1990s, NVIDIA created GPUs to solve this problem. GPUs were then used in gaming consoles and display devices like PCs and TVs to render graphics. It wasn't until the 2010s that NVIDIA realized that GPU's ability to process information in parallel also made them the perfect type of chip for a new industry that promised to change the world: machine learning. This is because, in order to run machine learning and eventually AI models, millions of bits of information would need to be processed in seconds, as the models scan all of the information on the internet to retrieve answers. And it just so happened that by 2022, when ChatGPT was first released, NVIDIA already had 30+ years of experience designing the world's most advanced GPUs, positioning them better than any other company in the world to take advantage of the AI race. And they've been so successful at that in just 3 short years, they've overtaken tech giants like Apple and Microsoft to become the world's most valuable company. Qualcomm is one of the industry's first fabless chip design companies, and still to this day is one of the industry's most wide-reaching companies. Qualcomm's name literally means quality communication, which reflects the company's focus on connecting wireless communication devices. Qualcomm originally focused on designing wireless communication, or RF devices and modems, for early mobile phones. They actually invented the technology that translates digital information into analog, or radio waves, and then back again, allowing mobile devices to connect to the internet and send and receive digital information. Now Qualcomm produces advanced chip designs for almost every type of mobile device, including phones, PCs, IoT devices, cars, AR and XR devices, and RF and Wi-Fi modules. Qualcomm is currently the world's 102nd most valuable company. Broadcom, like Qualcomm, also has its focus in the transmission of digital information. The Broadcom name means broadband communication. The company is focused on designing chips and hardware for communication, data center, and industrial systems. Their main products include networking chips for wired connectivity, broadband and wireless chips for Wi-Fi and Bluetooth, and mobile devices and infrastructure software. Most of their business comes from creating the networks that connect data centers, which is where all of the internet's information is stored. Broadcom is currently the world's 7th most valuable company, showing the immense value of becoming a critical part of the data center infrastructure. AMD, like Qualcomm, is one of the original semiconductor companies. However, unlike Qualcomm, AMD was originally founded as an IDM, not a fabless chip design company. It wasn't until 2019 that AMD spun off its foundry division, which became the world's 4th largest foundry. AMD currently specializes in creating GPUs and CPUs for PCs and data centers. They are a competitor of NVIDIA in the GPU market and a competitor of Intel, Qualcomm, and others in the PC market. MediaTek is the only non-American company in the top 5 fabless chip design companies. MediaTek, also similarly to Qualcomm, designs chips and SoCs for mobile devices like smartphones, PCs, and IoT devices. MediaTek is Taiwan's 2nd most important semiconductor company after TSMC, and is responsible for designing most of the homegrown Taiwanese chips. MediaTek is the world's 322nd most valuable company, but they are quickly growing and will likely challenge other top fabless chip design companies for the premium smartphone and PC applications. So that's it for today's video. I now hope you have a better understanding of the fabless chip design model, who the top fabless chip design companies are, and how they work with the wider industry to design and ultimately create the world's advanced computer chips. If you enjoyed this video and want to learn more about the semiconductor industry, be sure to subscribe to our channel. See you next time. Bye-bye.